most beautiful time on campus, and no one here to enjoy it. Oh, wow. Look at those Chinese pistachios. That's brilliant, though. That's okay. We'll be back one day. Okay, I'm back in lab, and I will be running some unknowns on the IR and NMR. I got them set up here. I'm going to make up all the unknowns for NMR tubes for the NMR, but I'm also just going to run them as liquids. They're all liquids on the ATR adapter. So I'm going to first look and make sure that looks clean, and that zinc selenide crystal, it looks clean to me. So I'll go ahead and run my background. I'll come on over to the software, and I'll go to, again, instrument, scan background, and then it's going to ask me how many or how I want to set it up. I'll just use all the default values. It's going to be 4 scans. Say OK, and then I'll patiently wait. It's going to be scanning the air in the compartment and also air inside of the instrument and other things inside the instrument. It should look like this if all is well. And it's coming up now. It is looking like that. There it is, looking good, right? Nice, that's what our background should look like. It's got all 4 scans done, and now it wants me to save it as background.sp, and I will save it as that, and I'm going to write overwrite. So it's going to overwrite the last background, and look at that, it looks great. So I'm going to use this background for all the unknowns. Actually, I'll just put them on one at a time and run them and clean them off, run the next, collect the spectrum. Okay, the very first thing I'm going to do is add some TMS to this NMR tube. So this TMS, this is the 99% TMS, this is straight TMS. And the reason why I'm using this is I have liquid samples, so I can just add a little bit of this TMS and then fill up the rest with my sample, and it'll be very concentrated. I'll get a good carbon NMR. So I got an old broken pipette here, let me get a new one. I first pipette up some of this liquid TMS. It'll probably drip out a lot real fast because of the high vapor pressure of TMS, plus, well, it's not too bad actually, but it's dripping out because, like as we suggested, like an elephant, it has a high vapor pressure TMS, and the pasture pipette is polar glass and TMS is non-polar, so it's not really sticking to the glass. As well, the glass is warm a bit, but actually it's colder fall day, that's probably why it's not shooting out much. I'm going to push it out the rest of it. Draw up some more, do that a couple times. Oh, it came out fast that time. Drop a few times, do this, and I'm evaporatively cooling my pasture pipette so that I'll get it under control. So it's a little bit drippy, but not too bad. Oh, see, oh, it's not dripping now. So now I can start coming over and putting a little bit in each NMR tube. Let's see if I can do this while I'm also filming. Oh, that dripped a little bit. Okay, I'll put a couple drips in this guy. A couple drips in this guy. Drips in this guy. Go down the line, get each unknown's NMR tube, get a little bit of TMS in it. Alright, let's see what those look like. Pretty good. That's a good amount of TMS right there. Yeah, go down the line, check out these other ones. Yeah, that one's looking a little low. I might have to add a little bit more, but actually, no, I think that's enough. This one, don't know. I think I'm gonna add a little bit more to that second one. Yeah, so I'll probably add a little bit more to some of these. And then I'll also mark off, like I said before. I'll put a line at 4 centimeters. I didn't do that yet, but I will. I'll use my ruler here. Use my ruler and a Sharpie. Put a line at 4 centimeters, not 4 inches, 4 centimeters. And then I'll have just this much TMS, say, as you can see in this one. That's a good amount right there. Then my liquid sample, my unknown, up to 4 centimeters, and we can run it on the NMR. Okay, I'm going to pause the video so I can mark off the 4 centimeters for everybody. Put a line at 4 centimeters for each one. So see this one here, it's got some TMS in the bottom. and it has a line at 4 centimeters. And I put that on all the test tubes. So each of your NMRs will be filled up to 4 centimeters. I'll put a little TMS in all of them. Okay, now for the unknown, I have my first NMR tube, and if you can read it, it says unknown. It has the number 1 on there. It's a little blurry, it doesn't want to focus, but I wrote in a number 1 on this one. And you can see it has TMS under in the bottom already, and a line at 4 centimeters. I'm going to add unknown 1 to this by pipetting it into my pipette and seeing if it drips a lot. Oh, this one's not too bad. It's got a pretty high boiling point, this guy. So I'm going to draw a little more up. I'm going to still, draw some up, spit it out. And then I will put it in the top of my NMR tube. And slowly start to fill until I get to about 4 centimeters. A little bit more, there we go. So I've got my 4 centimeters in there, looking good. And I'll pick a cap, whatever color sounds good for number 1. Maybe I'll go with a white cap for number 1. Okay, so I've got my sample number 1 prepared. I'm going to invert it to mix it. Make sure that TMS is mixed in there. 1 inversion is probably enough. I'll do a couple. And then this pipette I have in unknown 1. Uh-oh, you're getting a clue if you're looking about what it is, but you'll be able to figure out what these are easily now. What I'm going to do with this unknown now, since I already have my pipette here in the unknown 1, I'm going to put a little bit of that using this pipette on the IR, get the IR spectrum of it too, so it's ready to go. So let's go over to the IR and take it. Okay, so back at the IR spectrum looked good. We got our plastic from the inside of the instrument, just under 3,000. We got the carbon dioxide peak. I guess I'm breathing in the room. There's carbon dioxide in the room. And then some water. So anyways, it's looking good, and I like to delete it right now by hitting the delete key, because if I don't, it'll show up, the scan of my unknown will come out blue, which is fine actually for us because I'm going to screen capture it. But if we were going to print it over here to the printer, the blue, it's a black and white printer, blue comes out dashed and doesn't look that good. But anyways, let's go over and run our sample. So, okay, now for unknown 6. Getting down to the last few here. So our test tube, or NMR tube, we labeled 6. Looks like it's got a good amount of TMS in it. Got a line at 4 centimeters. And let's see how this unknown reacts to this, if it's going to be drippy. Not too bad, no. I'll spit it out, grab some more, fill this up to 4 centimeters. Looking good. Good enough. All right, let's see. Can I find a new color cap? Yes, I can. Black is back. There it is. Put all your money on black. Bam, got it. Flip it over. It's taking a little while. It's a bit viscous. It's sticking to the glass. That's actually a clue as to what this molecule is. That's pretty cool. Yeah, this one, it makes sense. When you figure out what it is, you'll know why it's sticking to the polar glass. There we go. Got it mixed up pretty good. Put that back, it's ready for the NMR. And then I'm going to take this over to the IR, get the IR spectrum of it. Okay, here we go. I've already cleaned off the IR zinc selenide crystal. Bring my sample over. Give it a drop. There we go. Come on over to the software instrument, scan sample. Okay, to the 4. And it's going. While we're waiting, let's look around. We got the NMR over here ready to go. Gonna run some samples on it. I'm setting up my computer. I'll move that. Remember, we got our spinner. Hit this button, you'll hear the air source come on. Hit it to turn it off. There we go. And when I come back, is our scans done? Whoa, they're almost done. Look at that, and they're done. Let me hit overwrite. Oh, look at that. That's definitely something you should recognize there, huh? right away. It should be screaming at you. Let me squeeze this screen like that. Oh yeah, there it goes. Boom. Okay. And then where did my text box go? I had it kind of disappeared on me. I think I got to make a new one. Actually, I'll come back to that. First, let me label these signals. Let me bring up the vertical cursor. There it is, over here. And what's this guy? Where is it at? Oh, 3308. We know what that is, right? Let's come over. Let's look. What does that look like? Oh, that's an alcohol for sure, huh? Ooh, alcohol sticking to the glass NMR tube. It's all coming together. Double click here. Oh, a little less than 3,000. We got some sp3 carbon hydrogens. Do you have any carbonyls or anything? No, we don't. No carbonyls. Look, we have just an alcohol with an alkane. Easy, easy, huh? All right, I'm gonna add the text box and print it. I'll screen capture it for you guys. Next up, unknown 6. I gotta eject unknown 5. Oh no, I grabbed the thing with my fingers. That wasn't good. I'll try to wipe off the grease I might have gotten on the spinner. Grab unknown 5. Let's see which one is that one. It looks like it's the purple one. Oh no, that's 7. Oh no, I'm doing unknown 6. I just ejected 5. Okay, this is unknown 6. So I'll put an unknown 6 to the top of the spinner. And then adjust its height. The depth gauge. Put it over back in the tube. And see if we can get it to spin. Drop it down by turning off the air source. Turn the air source back on. Yeah, it's spinning good. Yep, there we go. Close the lid. Go over to the computer and run it. So I was in the carbon NMR setting for the last sample. Gotta get to the proton. NU space H1, enter, and now I'm in the proton NMR setting, and then to run it, I do ZG, enter, enter. And it'll pulse all the radio waves in the 60 megahertz range. Cite our hydrogens, and then when they relax, they give me this FID, free induction decay. I'll go into nuts, bring it over. Oh, in nuts I have this meta object from the last sample. I'm going to get rid of that first because it'll stay there. I have to just type MO, oops, I typed the wrong thing, I gotta type MO, and then D to delete it. There we go, and then enter to exit out of that. Okay, so now I want to bring over my proton NMR. The command to bring that over is the letter A and the number 2. There it is. Ooh, this one's ugly. Actually, this particular sample is just an ugly one, I think. I don't know. Well, I'm going to shim it either way. Oh yeah, I think I know what this is. Yeah, this one's going to be a little bit tricky. We're going to need to set the TMS to 0 and to shim it. So let's go back to AII. And to shim it, we'll shim first. We'll type SHIM, hit enter, and then relaxation delay 2 seconds, hit enter. And it's going to start adjusting the electromagnets around the sample to make the magnetic field as homogeneous as possible around the sample. So you can see it's shimming the C and Y electromagnets now. It's adjusting those. And I said I need to set TMS to 0 and shim, and I did the shim first. I could have set the TMS to 0 first too. It doesn't really matter. So we'll wait. Okay, shimming is complete. So we just need to rescan it. So we type ZG, enter, enter. And it'll start scanning it again. Oh shit, it'll do 1 pulse of radio wave or 1 scan. And there's our FID. So now we'll go back to nuts and we're going to see, the previous pre-shimmed spectrum. We got to bring over that FID for the new one after the shim. So I typed the command A2. Oh, and then use over 2. I hit enter a couple times to get to the base level. The letter A, the number 2. Yeah, it looks about the same. I think this sample is just going to be a little bit tricky, and that's okay. So I'm going to zoom in on TMS. Let's set that to 0. Yeah, it's definitely shimmed okay as far as TMS. So I'm going to click and hold, get the horizontal line cutting through the TMS, type the letter M, and it's telling me the TMS is at 0.603. So I can fix that go back to AII PNMR. The command to fix the TMS is FO frequency offset. And where are we at now? We're at 0.603, I believe. Let's double check. Yeah, 0.603. So I hit OK. And then where do I want TMS? I want that at 0. So, okay. So let me scan again. ZG, enter, enter. Wait for that. Okay, that scan's complete. And now bring it back over to nuts again. So this was before TMS was set to 0. And if I type A2, it'll bring in the new data, and look at that, now the TMS is over here at 0. That looks good. Yeah, real close to 0. I could do a minimum peak height and see where it's at. So press and hold. Type M. And I'm at 0.017. Closest I've been today, close enough. I'll get back into zoom, zoom out, and I'm going to drag over my main signals. Right click in and then get out of zoom. And next up, a text box. Do N O A, and this is unknown 6, right? Yeah, unknown 6, and okay. Move that up here, and then hit enter to get out of that, and then I can bring this down. I don't need it quite so high. Do you guys know what this is? A big mess around 1, and then an ugly looking triplet around, upfield of it. This looks like a long alkyl chain. And we got a signal around 5. That looks like an alkene maybe, huh? I don't think it's an alkene, but I think we'll know what it is when we look at the IR. And now we need to integrate. So how do we get into integration? We type ID. When I do that, I don't see any integral lines. It's because they were cut up from before. I need to hit the letter C to clear all the previous cuts. There we go. And now I will cut this guy up like this. We'll go 2 clicks on the left, 1 on the right. 2 clicks on the left, 1 on the right. That looks like maybe a 1:2 ratio, huh? Now I'm going to get this big area here, and then this little area, 2 clicks, 1 click. I'm going to set the small one to 1. I'm going to click once, and I'm going to type V. And then I'll hit 1 for that. Enter. Yeah, looks like a 1 to 2 to maybe 10 to 3. This looks good. Maybe it's 5 CH2s to make 10, and then a CH3 methyl at the end of a long alkyl chain. And then a 2 hydrogen signal and a 1 hydrogen signal. Interesting. So I'll collect this data for you guys. Now to run the carbon NMR for unknown 6, it's in proton setting now, so I type NU space C13, enter, and then ZG to 0 go to get the scan going, enter, enter. Now just wait for those 12 scans. Okay, scans are done. I click OK, and I'm bringing it over to nuts. I'm in the integration subroutine, so I hit enter to get out of that. To bring over the carbon FID, I hit Control F3. And then I entered accept the default name, 0.5 for the line broadening. OK again to get this box gone. And look at that, it's looking pretty good. Looks like everything's like from 60-ish to 0. So I'll zoom in on those signals. I have a total of 1, 2, 3, 4, 5, 6, 7 signals. Okay. I hit enter to get out of the zoom subroutine, and I've got all 7 labeled here. I'll make sure they're the right ones. I'll click and hold, and I'll type M. Yeah, same thing. So then I'm going to get rid of these peak labels. So view peak labels. So just have that table there. It's nice, huh? And then, so I have a signal at 61. This might be alpha to an oxygen or something. Okay. And now add a text box, NOA, and this is unknown 6. Click OK, move that up here, and then hit enter to get out of the subroutine, and I'll collect this data for you.